In this video segment 2B, we describe the remaining activities in part 2 of the structuring numbers sequence, beginning with the anticipation activity. We ended our explanation of the previous activity, reasoning by moving the beads, by saying that as tasks of that type are used repeatedly, children begin to anticipate what the final configuration of the rack will be, even before they move the beads. The anticipation activity is similar to the reasoning by moving the beads activity. The teacher shows the initial number of people on the bus on her arithmetic rack. Children show that same configuration on their racks. Then the teacher says how many people get on or off the bus. But the difference is that in this anticipation activity, the children specifically are asked to not complete the task with the beads, but to do so only mentally. Crucially, they do move the beads on their racks to show the initial amount. In our experience, children often touch the beads they would move were they to complete the task using the rack. A few children are not able to complete the task only mentally, but they do so by moving the beads anyway. These children are participating at a level that is appropriate for them. Teachers that use this sequence successfully typically make gradual shifts in the activities they use. For example, after several days of using the reasoning by moving the beads activity, teachers pose several tasks of that type and then shift within the same lesson to the anticipation activity. Doing so provides opportunities for the more sophisticated children to continue to advance, while the less sophisticated students continue to complete the tasks by actually moving the beads. The shift is easy to make after posing several tasks where children complete the task moving the beads. The teacher can simply say, as she poses the next task, "This time, instead of moving the beads, just think about how you would move them and figure out what the result will be." Class discussion of the children's solutions is an important part of this activity. It is through the discussions that children link the way they move the beads to quantities the beads represent. And it is this linkage that forms the basis for reasoning using grouping strategies. The fourth task is reasoning without moving the beads. This activity is similar to the anticipation activity, except that this time the children do not have their racks to use. We have found that moving directly from the reasoning by moving the beads activity, where children use their racks to enact the entire task, to moving without the beads activity, where they do not have their racks at all, is too big a step for many children. The teacher shows the initial configuration on her rack, which remains visible throughout the task. Then she says how many people get on or off the bus. The children have to reason entirely mentally, but they have the visual support of the teacher's rack. After the class has had sufficient time to figure out the task, there's a class discussion. Children talk about which beads they imagined moving and how they used that information to figure out how many are on the bus now. One or two children may need to have their racks to use in order to participate meaningfully. If more than just a few children need to have racks to use, this activity is premature. This activity will be used often over many lessons, and as we discussed with the anticipation task, teachers typically combine this activity with previous activities within the same lesson. For example, the teacher may pose several anticipation tasks, then collect the children's racks, and then, or later in the lesson, pose several reasoning without moving the beads tasks. It should be apparent by now that the activities listed in this part of the sequence form an evolution of sorts. As children participate repeatedly in tasks where they move the beads, they become able to anticipate the results without moving the beads themselves. Nevertheless, the image of the beads is present to support their reasoning. To this point, we have discussed only additive tasks and subtraction tasks. An addition task, the teacher shows 8 people on the bus and says 6 more get on. A subtraction task, the teacher shows 13 people on the bus and says 6 get off. In addition to these two task types, here are two other task types that can be used productively in the reasoning without moving the beads activity. These are missing addend and missing subtrahend tasks. Here we give an example of each task type. A missing addend task. The teacher shows 7 people on the bus and says, "How many more need to get on to have 13 people on the bus?" For this task type, the teacher uses her rack to show 7 people on the bus. The children's task is to use the image the teacher shows to figure out how many more people get on the bus to have 13. During the subsequent discussion, children typically talk about which beads they would have moved had they had their racks to show more people getting on the bus. A missing subtrahend task. The teacher shows 15 people on the bus and says, "How many need to get off to have 9 people on the bus?" Children have to imagine to figure out how many people have to get off to have 9 on the bus. Here again, children typically talk about which beads they would have moved had they had their racks to show people getting off the bus. If they do not, the teacher can ask them which beads they thought about moving. In this activity, Imagination Bingo, the teacher shows the initial quantity on her rack and asks children to imagine some number of people getting on or off the bus. The children then cover the resulting number on their bingo cards. There's little discussion with this activity. Teachers typically call on only one child to explain how he figured out the task. Keeping the discussion to a minimum makes it possible for the game to move at a reasonable pace. This activity is appropriate only after most of the children are able to reason without moving the beads. Now we turn to various pragmatic considerations involved in planning a lesson that uses the activities in this part of the structuring number sequence. These include deciding which tasks to pose, sequencing tasks, and recording children's solutions. First, let's consider productive number choices. The structuring numbers sequence is about numbers to 20 with a focus on the teen numbers, while the patterning and partitioning sequence focused on numbers to 10. With that in mind, the tasks posed in these activities should involve going over 10. Examples include 7 people on the bus, 9 more get on, 4 people on the bus, 8 get on, 6 people on the bus, 6 more get on. Each of these examples involves going over 10. Examples not to use: 3 people on the bus, 5 more get on, 14 people on the bus, 2 more get on. These examples do not involve going over 10. Subtraction examples include 14 people on the bus, 5 get off, 16 people on the bus, 9 get off, 11 people on the bus, 4 get off. Again, each of these examples involves going through 10. Examples not to use include 9 people on the bus, 3 get off, 14 people on the bus, 2 get off. These examples do not involve going through 10. The second aspect of deciding which tasks to pose is to select the initial configuration. This selection is made by anticipating possible moves children might make with their beads that promote grouping strategies rather than counting solutions. Teachers we have worked with have told us that choosing the initial configuration from the large number of possible choices can be confusing for them. For example, if the teacher wants to use the task 8 people on the bus, 6 get on, there are many ways to show the initial 8. How might the teacher decide which configuration for the initial 8 is a good choice? In our work with teachers, we have found that making specific recommendations that have proved useful relieves the teacher of this difficult decision. Here are our recommendations. For addition tasks, show the initial number, which will be a number under 10, entirely on the top rod. Using this choice, children will typically show the second quantity either by filling up the 10 on the top and putting the rest on the bottom, or they will put all of the second quantity on the bottom. Notice that these are the solutions given by Andy and by Carlos in the first example we discussed earlier. For subtraction tasks, our recommendation is to show the initial number, which will be a teen number, as 10 on the top rod and the remainder of the number on the bottom rod. Using this choice, children will typically either empty the bottom rod, get down to 10, and take the remainder of the number off of the top, or they will take the entire amount off of the top. These are the solutions given by Darius and Gabriella in the second example we discussed. Certainly, other choices for the initial configurations are possible. However, by using these ways consistently, the teacher creates a situation for herself that is more manageable and one that guarantees that efficient grouping strategies will emerge in the discussions. Another aspect of lesson planning is deciding on the set of tasks to use within the lesson. The choices can have considerable impact on the learning opportunities the lesson provides. For example, suppose the initial task is that 5 people are on the bus and 7 more get on. After a thorough discussion, the next task the teacher poses might be 12 are on the bus and 7 get off. Invariably, somebody in the class will notice how these tasks are alike. Children often say things such as, "Hey, that's the same thing we just did." That remark provides an opening for the teacher to say, "What do you mean? How are these the same?" And in the ensuing discussion, the reversibility of addition and subtraction will be the focus, though neither the teacher nor the children will use that language. At the same time, there will be children that solve the second task without thinking about relating it to the first. These children will talk about which beads they moved or imagined moving and the relationship between the beads moved and the quantities involved. This discussion is also productive. You will surely be able to think of other examples of pairs of tasks that can promote number relationships. The second example we show here is to post 14 on the bus, 7 get off, as the first task, followed by 14 on the bus, 8 get off. We don't mean to imply that the teacher should make choices of this type every time. Rather, we are pointing out that such choices provide additional avenues for fostering a variety of number relationships. This concludes segment 2B. The next video segment, 2C, is devoted to recording children's solutions and to a suggested timeline.